what I wanted to talk to you today is a topic that's very dear to myself and to TriNimbus as a business. We see IT around us changing, and there's a number of different trends, number of different technology shifts that are fueling that change. So I wanted to go through a little bit of the history of that change and how we've seen IT changing and what recommendations we have for people that are working in IT, whether they're system administrators, server operators, network operators, IT architects. How does that impact their operations, their daily lives, their work, and what they can do to keep up with the pace, with the change. So it all starts, as you can imagine, with virtualization. 15, 20 years ago, it became more popular. Companies started adopting it as a way to package software together with operating systems and deliver their solutions. Arguably, it started the era of what we call software-defined everything, where you're simulating through software hardware in this particular case. So the software can focus on what it needs to do, which is running the application, and not worry too much about the aspects of the hardware behind the scene. What the virtualization ushered in a different view to how IT architecture was done. Traditional architecture was to look at systems top to bottom, including hardware. And as you're probably aware, this type of architecture still exists, where certain vendors are optimizing for a specific hardware so they can get more performance of the hardware. But that's not the majority of the architecture today. The majority of the architecture today is not coupled, not tied to a specific hardware, thanks to virtualization by a large part. It allows for the abstraction from the hardware between the operating system and the applications. It also supports these hybrid scenarios where the same company can run Linux and Windows in the same environment without having to optimize specifically for one or the other. It also ushered in the era of commoditization of hardware, particularly compute. Later, as we've seen, the innovation around storage and networking did the same. It allowed businesses to build server rooms and rack up all this compute that they could keep reusing as the business was evolving, different applications being brought in. They could keep reusing the same hardware because they didn't have to buy specialized hardware, they didn't have to buy something that supported their specific workload, and they could just keep adding. As they were scaling, they can add more hardware and allow those applications to scale with it. So I'm doing this very quickly. You know the story, just to give a little bit of backdrop of how I think these trends that I'm going to talk about will converge. It did start at the era of data centers, right? Compute became more and more requested. Companies built larger and more complex solutions. We've seen the advent of software as a service, and all those applications, all that software needed to run somewhere. So rather than you trying to run your own hardware and worrying about power outages, internet outages, whatever, you could outsource to a data center to do that job for you, and just either put your hardware or let them to manage the hosting part for you. So that's one trend. The other trend is in the software world. As we've seen more and more applications being developed for businesses, and this trend goes even further earlier before virtualization, there was a need for applications to interoperate, to integrate, to exchange data, and all of that. And as the different business applications got introduced, that need became bigger, but that complexity to integrate became harder to deal with because different formats, different protocols, different policies, and whatnot. And there's been a number of innovations in the software world. Probably most of the people in the room, I'm assuming, are familiar with the idea of an enterprise service bus that allows a company to create sort of an interface that allows applications and other businesses to integrate and communicate with them, while the internal systems are being sort of hidden behind the scenes, and the integration is done by the company, exposing a more standardized interface. We've seen the advent of 3-tier architectures, service-oriented architectures, where big monolithic applications were broken apart and developed as separate services with clear interaction, clear contracts and SLAs between the different services, how they're gonna exchange data and interact with each other. And we've seen the advent of protocols and standards like web services that allowed companies to standardize what that communication protocol will look like at a higher level, not at the low networking level, stuff like TCP, but at the higher presentation application level, where you could trust that the other party, if they use web services, and if you're using web services, you could talk to each other, which was much more difficult before because there were all sorts of competing standards and formats. This ultimately led to one other trend, this idea that companies can expose their internal systems through the concept of an API. APIs are not new. They've existed for a long time. That's how Windows, built their programming interface to allow applications to run and interact with file systems and whatnot at the lower level. But what's more interesting here is not so much the inside the computer kind of API. I'm talking about interfaces that allow a company to develop a service internally or host a service and allow other companies, other businesses to leverage that by talking through these programmable interfaces. So it's not only about exchange of data, it's also about being able to, run jobs, execute actions, turn events, pass messages, etc., between systems that have no idea what's running behind the scenes because they use a standardized interface to allow them to program and work with each other. Arguably, in today's world, we live in an API world. The APIs are the building blocks that are fueling a lot of the transformation we've seen around us. I like this slide, even though it's old. There's been an exponential growth in companies thinking, I can expose my services, I can expose my data through a common interface and offer it as API that allows to build mashups and very interesting solutions on top of it. It also led to this paradigm where we've seen companies developing products where first they develop the APIs, and then they develop the user interface for the business users, consumers, and whatnot to interact with the product. The products are first being built for developers and offered through APIs, so they're building platforms, and then through those APIs, a bunch of other developers from a bunch of other businesses are developing on top of them, add-ons, plugins, their own interfaces, et cetera, et cetera. So that's the second trend, right? The first trend is virtualization, where hardware became commoditized. The second trend is API first, where companies are building solutions that you can interact with through APIs without the need for a human to go through a UI and interact with them. And you can either outsource the UI building to a third party or build a UI for you for admin purposes, whatever interaction you want to have with the clients. Amazon Web Services is where we see this convergence of these two trends, where they have built a platform that became an API-first platform, as we are aware, back in 2006, 2008. It was built on top of virtualization, where they decided, I can expose services that do something useful, like processing payments, managing customer records, and stuff like that. But I can also expose services that allow others to raise some compute resources, whether it's storage, whether it's compute, and deploy their own solutions on my platform, right? There's a famous proclamation for Jeff Bezos where he essentially told everybody, you have to accept service architecture, you have to deliver services, you have to treat the other teams within the company as your customers. And there's this concept of two-pizza teams where small teams deliver a specific service, and there is a bunch of different small teams that do the same thing and they interact with each other through APIs, and they work with each other as if they were external customers, not as if they belong to the same organization. And that's how Amazon Web Services was built. That's how it was born. It started with queuing and storage and compute, and evolved since then to a variety of different services. I'm using this picture to step back a little bit and look at the infrastructure as a service concept and the cloud in general. I'm excluding software as a service when I think of cloud in the context of this audience. What allowed companies like Amazon Web Services that started this trend is to innovate, and rather than just offer raw compute, storage, and networking and take care of the physical aspect of hosting and running those resources, it allowed them to innovate because now they could actually not only run your VMs for you, they could start offering higher level services on top of that. You trust them with your data, you push your workloads into their compute resources, and in turn, they're learning from how you're behaving and how you're using their systems and saying, I can see a variety of customers struggling to run their MySQL database. I'm going to offer a database management service that allows everybody to manage the database efficiently without them having to do that, right? And that slowly starts another trend. It's this moving from what ultimately becomes commodity even in the virtualized world, right? VMs and virtualized storage and virtualized networking, it's a non-differentiating thing for providers. What's differentiating, what's interesting is going up the stack, offering these higher level services that are possible because the cloud exists, that are possible because there was the right approach with APIs, with service-oriented architecture, with the way virtualization was done, with the way the physical design behind the scene was done. It allowed the company to innovate. And this, I don't want to call it a trend, this going up the stack, but it does impact the life of the IT people, the IT administrators and IT architects in a fairly profound way that we're going to see later in the presentation. One of the things that the cloud enables is this notion of infinite scalability, virtually infinite. I should add, we live in a physical world, so there is a limit somewhere. Virtually infinite resources. I can request resources on demand and do whatever I want with them and then get rid of them. So you have concept of auto-scaling where resources are being added and removed based on what your load is. It does lead to a concept of, we call it, treat your servers as cattle. Do not look at them as pets. Do not name them. Do not bring them back to health when they get sick and stuff like that. Get rid of them and bring a new one. Just put a number on them and stuff like that. When you start changing your mindset and start thinking of compute resources, and I'm consciously using the term compute resources because there's many of them. It's not just VMs today. When you think of your compute resources as with the cattle metaphor, you start caring about the applications and how they're secured and deployed, not so much about the underlying server resources because they come and go. And that's what really profoundly changes the life of the IT administrators that have grew up in IT late 90s, during the early 2000s, and stuff like that, because they were used to, I'm buying this hardware, I'm managing these virtual machines, I'm managing them as pets. I know exactly which VM does what. I care about the CPU load on each individual ones and the memory and stuff like that. I know when to add more storage, etc. There's a lot of attachment to those compute resources of the past. And that attachment is preventing us to evolve and preventing us to take a full advantage of the cloud today because we take the same mindset, we point it to the cloud and we look at the cloud, it's just another data center. What this picture is trying to show, it's an architecture diagram, deployment, you don't have to think through the details. There's a lot going on. There's a lot of different things you can think. There is a load balancer that's fully managed by Amazon. You don't have to log on to load balancer and type some rules, etc. It's managed through some kind of different interface or API or scripts like that. The servers are coming and going. There is a database that is being fully managed by Amazon for you, so you need to find a different way how you're going to look at logs, how you're going to look at performance metrics and stuff like that. You can't just keep doing what you were used to doing. And it gets even more complicated when we look at cloud-native technologies like containers and serverless and stuff like that. How do you even think of IT in that world? Let's stay where we are right now. So what was the old van? I have one or two data centers. I understand where I'm running my machines. I have my switches and routers and firewalls, and I can control things. Became a lot more complicated. I'm managing firewalls and switches and routers here, and I'm managing network ACLs and security groups and VPCs here. And I don't even know what's running behind my load balancer, but there's this thing where I can add another listener and throw in an SSL cert, and I don't control how it's working, right? It starts to become so complex and so varied that it's very easy to get lost. It does develop a superhero mentality. It's not like the cloud-enabled superhero mentality. It existed for a long time, but it exacerbates it because now you have these people that invest in learning how to do their work, And they become good at specific actions, and when something happens, because they're not thinking how I can automate what I'm doing, they're thinking how I can fix. There's always stuff being thrown at them. There's outage, problems, failures, etc. They just go and fix and fix and fix, and they become the superheroes in the company, right? But they become superheroes within an IT-centric view where keeping the lights on is the prime directive, right? Not in a different world that is emerging here, where automating the clerical, the undifferentiated, heavy lifting jobs is actually the way how you're going to reduce your queue, your backlog of stuff you have to deal with. And it allows you to think what other services I can build myself, right? You can take a page from what Amazon is doing, what Microsoft is doing with these high-level services, and say, me as an IT, I can start developing services that are specific to my company. But you need a shift in that mindset and realizing I can make myself less busy through automating what keeps me busy today, so I can think as a developer to develop these new services, new functionality. And we're not even done, right? We're at the very beginning. This is just a funny picture of how the future state is still not defined. There's a lot of battles going on. There's a lot of evolution going on and stuff like that. We don't know where we're going to end up. Is hybrid going to be a thing of the future? Is private cloud going to be a thing of the future? We don't know. What we do know is cloud is probably here to stay in some shape or form. Public cloud specifically is definitely here to stay. API-driven automation around infrastructure is here to stay. There's few trends that we can recognize that we can predict they're going to be around for some time. We can't predict the rest. So the best we can do is learn how to cope with change, deal with change, and start changing ourselves. It really boils down to accepting that we live in a software reality. And when you accept that we live in a software reality, you can turn around and realize that there's been software programmers, engineers, application development groups that have been doing this for quite some time. And they've evolved from principles like waterfall to agile methodologies, from things like pair programming, code reviews, things like continuous integration. There's all these processes, concepts, etc., that existed in the software world. We never paid attention as much in the IT world. We never tried to, we never saw them coming as important, etc., because we lived in a different world. We lived in a world where operations was the prime directive. Things should not have been, they're not supposed to fail. We have to protect them. Change is not something we like, right? So it's very hard to change and adopt these principles that already exist, right? We don't have to reinvent the world. We don't have to reinvent the processes and the tools. They already exist. You just have to start thinking in a different way. If you start thinking that your infrastructure is code, and you can treat your, you can instantiate, you can create resources when you need them through scripting, through automation, in a programmatic access, it changes the way you start viewing your role. It changes the way you start viewing your job and the impact you're providing to the rest of your company, because it allows you to programmatically, and combined with the cloud, obviously, programmatically bring resources when you need them and start doing work, right? It enables experimentation. It enables dynamic thinking. It's no longer, I have 200 VMs, let me forklift them and run them in the cloud and nothing changes. It's like, I don't care that I have 200 VMs. I'm going to start enabling these models of self-service, allowing people to experiment, bring up compute resources, start playing with, I don't know, machine learning, whatever they want to play with, because I'm not afraid, because I've codified the way things are being provisioned and the way things are being configured, and I keep investing in that. It's a constant investment. You can't stop investing in that automation. We have one problem. There is a pretty significant gap in the IT community broadly. Programming skills are hard to find. People have to change. They have to start thinking as programmers. They have to start learning, languages like Python, Bash, PowerShell, whatnot, and start thinking, my job is not to click buttons. My job is to think how I can script these things. Luckily, there's been innovation in that space for operations and IT people, where rather than programming the way applications are being programmed, you can think modeling, using templating services that allow you to model your resources, model your infrastructure, and say, I need a network, I need a load balancer, it's going to go in this subnet, I need a group of auto-scaling resources that's going to scale based on CPU, and you model your infrastructure, you model your environment, rather than programming and saying, create an EC2 instance, add this disk, restart this thing, right? You don't have to think it in terms of atomic actions. You think in terms of what infrastructure I need to run. And these templating languages, and there's a few out there. Amazon has one called CloudFormation. Third-party HashiCorp has another one called Terraform. Microsoft has their own Azure Resource Manager, right? The cloud providers and third parties are thinking, what can I do to make the life of the IT operations people easier? And not only IT operations people, there's developers crossing now because this is attractive. I'm a software developer. I hate adding features to this huge application that I don't even know what it does. I like this idea of programming and scripting, playing with quote-unquote hardware in a virtualized world. So we see developers switching because they're interested. This is attractive. They can see the whole solution end-to-end. They can deal with very interesting problems. How I'm going to scale to millions of users, right? Where as a feature developer, you don't see that. You don't worry about that. Somebody delivers your code, and you have no idea how it, how your unoptimized query is going to make someone's life miserable. Templating also allows us not only to codify the infrastructure, but to start evolving that infrastructure. I can push a change. I can use the same template to create a staging environment that looks exactly like my production environment or a QA environment or a UAT, and make a change, test that change before I run it in production. How do we do things in production without coding, without templating? We go to a firewall, and we click and we add a rule. And if you're lucky, somebody sits next to us and say, I think you should put 5 there, not 4. And there's 2 people trying to help each other. With coding, you're trying it. You have your own little bubble, your little sandbox where you can try your changes. You push them to somebody to code review and say, oh, you know what? This is a better choice. I've done this yesterday or 2 weeks ago. It caused these problems. You go and change it. You iterate on it, and then you finally push it in production. So there is a very, very different approach. When you think code on the infrastructure side, it does allow you to look at what processes are successful on the software development side and try to bring them over. We've heard things like continuous integration. Continuous integration works with infrastructure code as well. I can take a change, build an environment, apply the change, and see whether anything will break. I can unit test my infrastructure as well. There's all sorts of things I can do. I can start investing in doing this type of unit testing and deployment testing, integration testing at my infrastructure code level, which was impossible to do in a physical world, or even VM world was very, very challenging to do. Much easier to do it in the cloud, and much more cost efficient because this test may run for 2 hours. I only pay for 2 hours using those resources, as opposed to my data center. I have to acquire all that hardware and keep it, and everybody wants that hardware obviously when it's there. So 2 weeks later, I lost it. I can't do my CI anymore because somebody else took it over from me. So hopefully I've summarized a little bit the new rules that we see that are coming into the game of IT, if I view IT as a game, where when I accept cloud is here to stay, when I accept that APIs, infrastructure as code, templating my infrastructure, thinking about infrastructure provisioning and configuration management as code, now I have changed my role. This is where DevOps comes to a realization. When we say DevOps, we mean a couple of different things. One is I'm probably jumping ahead of me here in my slides, but that's my jet lag. What DevOps really, what we mean when we think DevOps is we think developers in operations as one perspective of it. There's many others that I'll talk about later, but you see yourself as a developer. You're just on the other side, on the infrastructure side, not on the application side, but ultimately you're a programmer, developer, a coder, however you want to be, engineer that looks at operations and looks at automating whatever operation needs. And once I see myself as a developer, now I have to adopt practices that my fellow developers in the product side, the application side, are following as well, right? They're doing something like code reviews. One of the probably most impactful thing you can do if you're running a DevOps organization within your IT is to start practicing code reviews. Any change gets submitted to a second person, and that second person takes a look at it and finds issues, etc. And by the time it actually hits production, there's been several people reviewing it, and it's already a far better code, far better change. Not only the infrastructure provisioning piece should be considered code, your configuration is code as well. You have to store your configuration as well. Exceptions are passwords, security credentials, stuff like that. You need to sort of put them in an encrypted vault and manage them a little differently. They're not code because of the confidentiality and the security aspect of it. Otherwise, everything else is code. So when you have configuration being pushed in as a code, and somebody hard codes an IP somewhere in the configuration, code review will catch that and say, why are you hard coding an IP? I can't move this, and deploy it in a different environment. So you allow not only to look at the code for provisioning infrastructure, you're looking at the configuration and saying, hey, there is issues in the configuration as well. There's bugs in the configuration as well, right? Because the whole thing becomes managed as a software. I use the term infrastructure as code a lot. It became popularized through a number of different tools, a movement around this idea of configuration management, where some of the tools that I have on the screen, like Puppet, Chef, Salt, etc., are allowing you to template how you're generating and applying your configuration as well, right? A system is being provisioned, the system is being set up with runtime components, application services, etc. So finally, your application code can be deployed on them. And these tools help you, rather than maintaining all sorts of files somewhere that are hand-coded by somebody typing values. You can use systems like this to generate those template files, configuration files, and whatnot, and deliver them into your environment. I mentioned the concept of continuous integration. On top of continuous integration, we know, companies like Google, companies like Etsy, companies like Facebook, whatever, they practice what we call continuous delivery or continuous deployment. We can start thinking about the same concept of when a change is being delivered and approved by somebody, that change can go through an UAT test or staging test or even being deployed to production. Sorry. We can start applying that same principle to our own small organization. We are not Google. We don't have the resources that Google has to do this, but because the tools exist, the cloud enables this, I can start investing in test automation. I can start actually practicing continuous deployment myself. This is obviously easier said than done. There's a lot of investment required. Just enables, right? All the trends that we've seen converging and all the capability the cloud provides to us and all the tools that are maturing the ecosystem around us enables us to start thinking, I'm not Google, but I actually do pretty darn well something similar to what Google does because these things are available to me, right? It is still quite a lot of effort. There's all these things I need to worry about, how do I provision my infrastructure, how do I configure it, bootstrap things, I need to manage dependencies, I need to have my packages somewhere available, I need to store my credentials in a vault and secure them. There's a lot to think, right? And thankfully, Amazon Web Services specifically allows you to leverage a lot of tools that are built into the platform. Many of the concepts that are here on the screen would be either free because they're just a service that manages resources, you pay for the resources, or relatively inexpensive because you pay only when you run them and you don't deploy million times a second or a minute. So the real cost of using these resources, thank you. Failure of organization. Oh wait, I'm part of the organization. So the world of continuous integration, continuous deployment, DevOps can look scary, but the point is that there's a lot of innovation, a lot of tools being brought to the market, some of them available by the platform provider, the cloud provider, some of them by third parties. Investing in learning them is going to allow you to deal with that complexity. And obviously, hiring a consulting partner like TriNimbus will help you too. There is I kind of mentioned it already, there is a bit of a dark side to the infrastructure code because we didn't bring IT to think as programmers. There's lack of programming skills, but there is also a bright side. And the bright side is when we invest in our system administrators and server operators, et cetera, to become automation engineers, to think scripting and programming, now they can leverage those skills to a lot more on the operation side. Operation is not just about getting some infrastructure provision and deploying applications on them. I still need to worry about backup and restore. I still need to monitor things. I still need to handle my logs. I still need to do all these different things that the application dev team doesn't care and doesn't have a process I can borrow from, right? But what I've done is, that's the bright side of things, that's the upside. I've invested in skills on the IT side of the house that I can leverage to start thinking about automating these things and reducing the effort, introducing more efficiencies in the other side of what I need to do as an IT professional that runs operations, and I can leverage those skills. And there's a bunch of different tools. We actually have some of those sponsors today that you can leverage to improve your security, to monitor things better, to handle your logs better. Use those tools, deploy your tools, right? Because in the cloud, it's so much easier. Some of them are actually hosting their stuff, and you use them as a software as a service type model, so you don't have to run them. You don't have to learn, how do I deploy Sumo Logic and scale it and make it fault tolerant? I don't have to learn any of that. Sumo Logic does it for me, and hopefully they're a sponsor because I gave them a plug. And finally, I wanted to address, I mentioned DevOps. It's another convergence on the process side, right? We've seen convergence on the technology side and the way of thinking. On the process side, we've moved from the world of waterfall thinking, I have to design, gather requirements, design, think about how things will fit together, start developing, doing testing, to more of an agile model where I'm doing discovery and incremental changes in smaller chunks, right? And I'm reducing dependencies, I'm reducing waste in my organization. If you extend those agile principles that exist in the product application world to the IT and operations world, this is what comes as what we call DevOps. Bottom line is that there is two sides of the coin here. The one side commits to deliver infrastructure as code to the other side, right? So the operation side is also programming, and they're committing to deliver to the other side the scripts and automation, et cetera. And the development side commits to use whatever the operation sides have delivered and work together and plan how they're going to continuously support each other and deliver changes, et cetera. And that creates collaboration. The bottom line of DevOps is about collaboration. I like to say DevOps is going to be successful when we stop using the term DevOps because it's just the way we do things. We don't need a name for it because it's second nature, right? We only need it as a transition right now to think about it because that's not how we came to be here. We have to change, and it's part of what drives that change. There's a lot of other aspects that I'm simplifying here. It's about developers carrying the pager. It's about operations, people going and joining Scrum meetings and influencing people and saying, no, you cannot use that technology because it's going to cause problems for backup and restore. I know you don't care about that, but I care, and I'm going to talk to you to switch to different technologies, stuff like that, right? There's a lot more to DevOps than what I'm describing here, but it's not important whether you understand it. It's not important how you use it. What's important is to think how I can have interaction between the dev side of the house and the ops side of the house, and they deliver to each other code, and they start collaborating through that code together. There's a lot of ways how DevOps is being abused or misused, or people not understanding it or thinking they can put a DevOps engineer in my title, and all of a sudden I'm doing DevOps. Or I'm going to create a team of 3 people, call them DevOps team, and all of a sudden I'm doing DevOps. DevOps is not something like that. It's really a way of thinking. It's a culture. It's not a tool. It's not a team. It's not a person. You have to champion and progress through the organization to accept that it's a new way how we're going to deliver changes. It's a new way how we're going to deal with changes. It does permeate all sorts of different organizations. We all think of DevOps today in the world of startups, software technologies, but I know quite a lot of enterprises that are doing development. Maybe they don't call it development, they call it delivery, they call it implementation, they call it systems integration. They have different names, but they're doing development. And maybe that's not thousands of lines of code or millions of lines of code they're producing. It's an XML file they're managing for some integration or some template here that they're changing or whatever. But you can start applying the same mindset there. Invite IT to be part of it and say, here's these 2 systems I'm trying to make work together. Or I need to bring this other third party, and I need some data from this system here. Let's work together how you can enable me to create a sandbox of that so we can start developing this together. So these principles of Agile and DevOps apply to enterprises as well, not just software technology companies. If you believe what I believe is every company will be a technology company eventually, and the category technology company is going to lose its meaning, it's good to start thinking right now. Your business will, enabling experimentation, collaborating, your business will only benefit. It's not going to be negative. Yes, there's the fear of I'm busy, I'm the superhero, and things may break, and I don't have the time. But you have to work hard and find somebody who's going to help you create that time and start working together. So finally, all this is to start thinking about IT that starts delivering value to the organization by creating these building blocks and fitting them together. Your role as an IT professional or an IT organization is to think, what other tool, what other building block I can create, what other service I can create that people are coming to me and are asking me to do things. Oh, they need access to logs. Let me script so I can deliver logs to them, or let me bring another tool. Oh, they complain that restore took a lot of time because backups were done on tape. So let me look at what cloud technology I can use to improve the speed. I'm doing backups and restores and stuff like that, right? And you're creating these small building blocks that deliver value, that are providing a service, that are creating tools. And by putting them together, you start to create a bigger value. Things start to emerge and allow you to move faster. So the question I mentioned earlier, we focused on virtualization, focused on cloud, infrastructure as service, manage hosted solutions within the cloud, like, let Amazon manage your database. What about containers? What about serverless? Is that going to change things even more? Yes, it's going to change even more. It's going to be even harder if you're not starting now to change how you manage your VMs, to go into the world of containers, etc. But a lot of these principles still apply. Infrastructure as code is ever more important. DevOps is really the only way how you're going to operate in this type of environment, right? If you're in making those investments today, by the time your developers are going to bring containers to you and you need to host them and manage them, you'll have shifted your mindset. You've invested in skill set that maybe you don't have right now, and allows you to deal with that change and deal with that. And who knows, containers and serverless could be just a transitional thing. They may not exist 5, 10 years from now. There could be something completely different, but we are prepared for that change because we've shifted the mindset and we are working with the deployment in a different way. So bottom line, we need to start thinking about APIs ourselves too. It's not only consuming APIs. Don't put yourself in the consumer end of it. Also start thinking about producing APIs. When I create a service or a tool that I want to deliver to the rest of the organization, do I really want to deliver it just as a UI that an operator clicks through, or can I actually start offering it as an API myself, right? Put yourself on the other side. Now you're a vendor to the rest of the organization. You're a provider to the rest of the organization. As a provider, what do you want to deliver? Ideally, in my perspective, you should think about delivering APIs and allowing others to self-serve themselves and integrate those APIs in whatever tool they're using themselves, whatever system they have on the other end that allows them to do business. Finance wants to somehow provision compute resources, let them do it, right? Because you've created an API and they put it in their finance system and there is a button there that somebody can click and provision something for them to run, right? I don't know, run a report that they need to do it once a month. Why should you put a request to a DBA to go and create the data? You just build it and give them the button. That's what I had to say for today. Hopefully I'm on time. I don't think we have time for questions, so thank you.